Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, in the previous video of polymers, we discussed about different classification of polymers based on different criterias. We discussed about the mode of polymerization, that is the addition polymerization and the condensation polymerization. Today I am going to start with general methods and mechanism of polymerization. So let us start with general methods and mechanism of polymerization. General methods and mechanism of polymerization. The first method is chain growth polymerization. Chain growth polymerization is also known as addition polymerization. Addition polymerization. Chain growth polymerization or addition polymerization is generally seen in those monomeric units which have unsaturation in them. It means which have, a kind of formation of free radicals they favor. Okay, so it involves a series of reaction in which the reactive particle is a free radical. It is a free radical. The reaction intermediate is basically a free radical. Free radical mediated reaction. Okay, the monomers they get added by a series of chain reaction which involves either the free radical or a cation or a anion. Mostly the reaction involves the formation of free radical. Okay, it is an important reaction of alkenes as a monomer or conjugated dienes having more than one double bond, two double bond. Unsaturated monomeric units. Right? So the monomeric units for chain growth polymerization is basically it involves the addition of either free radical, cation or anion. Most common is the free radical mediated reaction. It involves the monomeric units having unsaturation, whether they are conjugated dienes or alkenes. Okay? Examples: formation of following polymers like polythene, PVC, Teflon, polypropylene, polystyrene, etc. The mechanism involved for this type of reaction, polymerization, that is chain growth or addition polymerization, free radical mechanism, cationic mechanism, or anionic mechanism. Okay, now each mechanism needs an initiator, an initiator of the corresponding nature, whether it is free radical mediated, cationic, or anionic. It involves three steps. First is the chain initiation step. Second is chain propagation step. And the third one is chain termination step, as the normal free radical substituted mechanisms offer. Okay. First is free radical mechanism. It is initiated by an organic peroxide which act as an initiator, or we can use free radical generators. Okay. The first step is chain initiation. Organic peroxides, they undergo homolytic cleavage, means symmetrical displacement of electrons, homolytic cleavage, to form free radicals. Means the type of bond fission is homolytic. Okay, to form free radicals. For example, suppose we take benzoyl peroxide or any of the alkyl peroxide. It is carried in the presence of heat or sunlight, okay, to form a free radical. The bond electrons will be symmetrically distributed. This bond electrons, okay, I'll make it red. Okay, to form this is the free radical which is generated. Okay, now this free radical undergoes rearrangement. How? This bond will undergo a homolytic cleavage. Now this unpaired electron and this unpaired electron will make a double bond to form CO2 molecule, and the alkyl free radical is generated. Okay. In the second step, which is chain propagation step, this free radical react with other reacting species to give different free radicals. Okay. Like for example, free radicals attack on alkene molecule to form a new free radical. The pi electron cloud I will show with the help of these two red electrons. Okay. Now, symmetrical cleavage. Okay. This unpaired electron and this unpaired electron will make a bond, and the R will attack to form RCH2. Okay. It will attack for other molecule of alkene to make a structure, and this way the carbon chain they attach with the n number of free radicals generated, okay, to form long chains. Okay. Now, chain termination step. When two free radical chains combine to each other, the reaction gets terminated. Okay. Like if I am taking two such units, okay, they will combine to each other. So this is the final product, which is a long polymeric chain. Okay. Usually in free radical reactions, benzoyl peroxide or tertiary butyl peroxide is used as an initiate. Common initiators. Right? Ferrous sulfate plus hydrogen peroxide mixture is also used as initiator. Okay, so this is the free radical mechanism. Now we are going to talk about the cationic mechanism. Okay, so the free radical addition simply follows chain initiation, chain propagation, and chain termination steps in the presence of benzoyl peroxide or tertiary butyl peroxide or any peroxide in free radical initiator, whether it is ferrous sulfate and hydrogen peroxide mixture. Okay, this mechanism is initiated with the help of protonic acids, initiated by protonic or Lewis acids. Okay, like H2SO4 in case of protonic acid, BF3 in case of Lewis acid. Okay, in water. Same chain initiation. The acid delivers proton okay if we are using HF, BF3, BF3, OH minus along with H plus. The proton attacks on the carbon-carbon double bond. Second step is the proton attacks on carbon-carbon double bond to form protonated alkene. To form protonated alkene, this is protonated alkene, that is carb cation. Okay, now the chain propagation step, which is the second step. The carb cation or the carbonium ion combines with another molecule of alkene to form a new carbonium ion, like pi electron cloud will attack on this carb cation. Okay, this butyl carb cation combines with another molecule, and these molecules they can be of n number. Okay, n molecules of, understood? To form the chain growth like this. When two such carb cations they combine with each other, okay, or if they combine with a negative ion, chain termination step. When this carbocation combined with negative ion, the reaction get terminated or loss of proton. Here, two same molecules of carbocation, they are not going to make the product, okay, as free radical mechanism was doing, okay. So this is very important to, satisfy this positive charge, okay, with the help of nucleophile, negative ion, or it will release H in the form of H plus, okay, like this. So what will happen? It combines with HSO4 minus to form plus H2SO4. So in this way, the compound can be framed. Is it clear? Okay. Now is the anionic polymerization. It is initiated by an anion which can be bases or nucleophiles or both. Here the intermediate which is formed is carbanion. Rest all remain same. Okay. Like potamide K plus NH2 minus of L plus NH2 minus, where L plus can be a metallic atom. Okay. So in anionic mechanism, polymerization, everything remains same, okay? But what we have to do in the last step, we have to make it react with a positively charged species, okay? The most important thing in this is, like for example, in chain initiation step, like for example, this is the nucleophile, it is attacking on the nucleophile will attack on this carbon, the bond will shift here, okay? And this will further form the chain propagation step and the chain termination step. The same thing happens will attack here to form the long chain. Okay. Now there's an important term about chain transfer reagents. How will you identify? How will you get these change transfer agents. For example, in vinylic polymerization, vinylic carbon which is sp2 hybridized, allylic carbon which is sp3 hybridized. Okay, so in vinylic polymerization, various other molecules react with the main growing chain. React with main growing chain. Okay, to stop or to interrupt the growth of original chain. Okay, by the effect of these chain transfer agents, the molecular mass, the average molecular mass gets lowered. Okay, and that is why they are known as what? Chain transfer agents. The common chain transfer agents are carbon tetrachloride, carbon tetrabromide, etc. Styrene, it reacts with this initiator to generate a free radical. Further attack with the molecule like carbon tetrachloride. So carbon tetrachloride CCl4. Okay, so CCl4 it can be written as CCl3 bond Cl. Okay, so this Cl will get off to attack on this carbon from this compound. Okay, now the same molecule will attack again. Again, it can be written as what? This is the free radical. Now the bond will break, attack here. CH2 combines with CCl3, CH. Okay, so this CCl3 basically attack here. Now styrene, CH2, same it will repeat and repeat. So this is the chain transfer agents. Chain transfer agents, they help to determine the chain reaction and inhibit further polymerization, also called inhibitors. Okay, so these agents basically help to determine the growth of chain. Now the second category of polymerization reaction is what? Step growth polymerization. Known as condensation polymerization. In this type, monomers which are going to combine, they usually contain two functional groups. Okay, that is difunctional monomers. No initiator is required. Each step is a mini reaction. That is why it is known as what? The step growth polymerization, because the polymer is formed in different steps. Okay, step growth polymerization. Like A plus D are two monomeric units. They condense to form a dimer. This reaction is also known as condensation reaction, as this reaction involves the removal of it involves okay, it involves the removal of simple molecule like water, ammonia, like etc. So they combine with this dimer, okay, to form step by step growing process. Okay, this is the step growth polymerization. Examples are nylon 66, bakelite. They all are step growth polymerization, result of step growth polymerization or condensation reaction. Decron, which is polyester. Okay. Now we are going to talk about separately about different polymers, starting with rubber. Is an elastomer. It is of two types: natural and synthetic. Okay. Natural rubber, it is obtained as latex from rubber tree. Obtained, they are basically obtained as latex from rubber tree. Okay. The latex further is coagulated by coagulated by acetic acid or formic acid. Okay. Now, natural rubber is obtained as a latex from rubber tree. The latex is coagulated or precipitated by the acetic acid or formic acid. Now, the raw natural rubber is very soft, gummy and sticky mass. Okay, sticky mass. It is insoluble in water, dilute acids, alkalis, but soluble in benzene. Okay, benzene, non-polar solvents, chloroform, ether, petrol, like that. It absorbs a large amount of water and it has low density and tensile strength. Okay, so you have low density, low tensile strength, water retaining properties very high. Very high. It's a polymer of isoprene, that is why polyisoprene, which is 2-methyl butadiene. Okay, isoprene is a monomer of natural rubber it undergoes polymerization to form natural rubber. Okay, this is about natural rubber. Then synthetic rubber. Synthetic rubber is just this methyl group is basically replaced by chloroprene. Mostly derived from mostly they are derived from butadiene Okay, they contain carbon-carbon double bond. The synthetic rubbers are either homopolymers, they can be a homopolymer of 1,3 butadiene. Other examples are neoprene. Okay, so synthetic rubber is having different properties in comparison to the natural rubber. Now, vulcanization of rubber. Process of heating natural rubber. Process of heating natural rubber with sulfur impurities to improve the cross-linking. To improve cross-linking. Okay, this process of adding sulfur to the rubber is known as vulcanization, and it was introduced by Charles Goodyear. Natural rubber is thermoplastic. Having no cross-linking, but vulcanized rubber, it gives the cross-linking which maintains the shape. Okay. Nowadays, vulcanization, the chamber, it includes some additives such as zinc oxide, which are used to accelerate the rate of vulcanization. ZNO is used to zinc oxide is basically used to incorporate or help the vulcanization of rubber. It helped to accelerate the rate of vulcanization. Okay, this is the vulcanization of rubber. Vulcanization of rubber comes up with high tensile strength. It is hard and non-sticky. High elasticity. Wide range of temperature. This rubber can be used as or can be used in wide range of temperature. Okay, so my dear students, we have discussed about the rubber which is polyisoprene. Okay, We will be discussing about different polymers in the coming turn. Till then, bye bye. Take care. Stay safe. Stay healthy.